AudioLab, devlog number 12, I think. So last time I did not have a whole lot to show because I was just working on a lot of invisible tasks, just like things that need to get done for this to be finished but that aren't very showy or interesting. This week's a little better. It's a lot of the same stuff. This application is still very much in that phase of software development where I just have to tie up all the loose ends that I've left for myself. But a lot of loose ends have gotten tied up, and this thing is just feeling better in a lot of invisible ways, and this time, finally, some visible ones. So, one thing that I did that is, well, let's start with an invisible thing. Like, a bit of technical debt that I had left myself was that, like, each one of these screens, you know, here's the general synth screen, the sequencer screen, the SFXer screen, the audio editor screen, which doesn't look like much when I don't have audio loaded, but, you know what this is. Each one of those used to be just a completely isolated chunk of code that didn't share, like, any of its UI code with the others. So that was a refactor that needed to happen. So now they all inherit from this application screen superclass. And there's a lot of shared functionality implemented in here that handles stuff like, you know, what goes in the menu bar, what does undo mean, as far as, like, everything but the exact details of, like, reverting and unreverting things like this. Oh, I have undo on the screen now. So, yeah. It's not implemented super well, but, like, it's there. It works. I think. Works for my purposes for now, at least. But, yeah, anyway, so just, like, all this stuff... Like, all of the, okay, yeah, so I know this will look weird to everybody who's not me, because I do this weird, like, home-built object orientation system on top of C, but anyway, these are basically virtual methods, you know, method overrides, function pointers that I set to something in all of these. So, like, for general synth screen, it gets its own call to menu item action, so for every unique menu item that's in here, which would be stuff like play overlay diff, because this is the only screen that does that, send to audio editor, because like that has to send this specific thing. Oh, this is actually a new thing, so I can just basically like automatically copy, you know, without using the clipboard or anything, whatever has been output to this synthesizer straight to the audio editor here. That has come in extremely handy. It's a very good feature. But anyway, yeah, so just all the little details that are different about these four screens are method overrides, and all the details that are the same are now handled by this one shared thingy that does a lot of stuff, just reduces code duplication. That's what a lot of refactoring is about, just reducing code duplication, sharing functionality that needs to be shared. Right, yeah, these are just default implementations of the methods that are supposed to be overridden. So if you forget to override any of them, well, you know, it doesn't really matter. I say you. I'm the only one who needs to worry about this. Anyway, so yeah, so that's just a refactor that's a little nicer than work that needed to get done. And now that it's done, just like these files are all smaller and have less duplication in them. They're still pretty big. General synth screen, 1288 lines. Audio editor screen, just under 1,000. Sequencer screen. Ooh, this one's a big one. Just under 1,600. SFXer screen. Yeah, all right. So they're all around the same size. Anyway, so that just makes my life easier. Made it a little harder for a bit, but then I made it harder to make it easier later. So let's go back to this silly Explorer sound thing that I keep messing around with. Right, so here's the one that I was working with. This familiar thing. I think I understand everything that's going on in this file now. It was an interesting thing to unravel. So right, last time I zoomed in on this and showed at these peaks and also the, let's see, how do I, yeah, and also at the valleys, there's just like a bunch of noise. I thought that I had remembered recording this directly from my 2GS emulator. But no, this is actually compressed audio re-exported as a wave, and all that I was seeing in here, I discovered, these are compression artifacts. This is not actual audio output done by the Apple II. This is something else. So I got a cleaner recording. Now, also we'll see, this one's fairly long. If I zoom all the way out here, I got some performance problems for drawing a waveform that's this long. This is like a couple of minutes long, this audio file. because I tried to capture like all the different sounds that Explorer can make, just for fun. Is this even a minute long? This is, yeah, about 2 minutes. So yeah, this is something I need to optimize because it's every frame that it tries to draw, it analyzes the entire waveform and inspects every sample to decide, like, for each column whether to draw, you know, how large of a line to draw. So if I zoom in, everything gets better. Anyway, but I think here's the sound I'm looking for. Please put the cursor there. Okay, so I got some things happening not the way I expect. I should fix those. Anyway, yeah, so this, you can already see without even zooming in that it looks a lot cleaner. So if I zoom in, there's still something there. I don't know what this is, but like this is at maximum zoom. So I can do something with this now. Let's do a thing. Let's trim to selection. Oh geez, okay, that made me very zoomed in. So now my selection contains only that, so I'm going to zoom all the way out in both, and I'm going to center that. That didn't center, you're still... Oh no, my center item doesn't work? Or maybe it does. No, clearly it doesn't. Oh, okay, I think I see what was going on there. All right, complicated to explain. I have a minor bug to fix there. But anyway, then if I normalize, so I make that as loud as, you know, the top peak is at full volume. Ooh, it looks like it's above. This is not drawing that line. Okay, got a couple of like little off by ones and things going on here. But anyway, so let's hear just the interference. Okay, it's very short. Okay, well, it doesn't sound like much of anything. Anyway, let's go back to where we were. A bunch of undos. Go here. Okay, so anyway, yeah, so there's nothing extra going on in the up-downs. So I finally, with another feature I implemented, managed to track down what was going on that's making this sound so much dirtier than just a square wave at about this frequency. So when I was measuring the frequency, I noticed something a little weird. This is a much better explanation than everything else that I thought I understood about it. If I go to... Right, so I used to be able to snap to just rising 0, falling 0. Now I can do any 0. So it's just a combination of these two, basically. So my cursor snaps to the ups and the downs. So what I can do for this is I can select just like half a cycle or a full cycle. I mean, you can already just see it here. This is clearly longer than this. So if I measure... Oh, and I have this other thing here. So it was pointed out to me that it's, I mean, something that I already knew, just wasn't thinking about, is that like the longer section of something, a waveform like this that's measured, the more accurate the hertz value is. And I had this configured to just be able to measure like one cycle. So that's about 111 points. Okay, so whatever that is, let's take that over to here and make a pulse wave at that frequency. So that's around what I'm measuring there. Doesn't sound quite right, but you know, it's not super far off. But anyway, so that's measuring 111 hertz and change. But then, like, so I can also, with this little thing, I can measure a different number. So this is measuring one full cycle. This UI is not great, but you know, it's there. So if I measure like another half cycle, I can step this up. That's still 111 hertz and change. Now if I step up to here, 2 full cycles, 107, that changed by a lot. So if I measure just a half cycle, for example, 97 hertz. Yeah, but a better way to look at this really is just the number of frames I have selected. I'm gonna fix this UI at some point. This is another just like pile of mess that's gonna go into a better format, like I did with the big mess of buttons in the bottom left. Getting there. It's on the to-do list. Anyway, so 246 frames, 215 frames, 215 frames, 216 frames, you know, rounding error, etc. 246. So it alternates between those values, like 246-ish, 215-ish. So it's like basically the duty cycle is changing, or there's like a frequency modulation being applied very quickly. What I assume this is just like CPU cycles on the Apple II, you know, sometimes it runs one cycle longer, or like rounding error with the way it does its ups and downs with the pulse duty cycle. So anyway, to reproduce this dirty sound, I would want something like, I haven't actually managed to make a perfect reproduction of it yet. Yeah, you're loud, I get it. But the closest I could do would be something like, say, a okay, I'm going to make you quieter and shorter because otherwise you're just going to be unpleasant. Sure. Let's get that somewhere around the same length. Somewhere around. Close enough. So this would be something like a stair step. Okay, yeah, so I started with the... Oh, shoot, you lost your frequency. Ooh! When I switch from flat to stair step, it should inherit the frequency of my flat for the first thingy. But anyway, let's measure this. Measure this again. Half a cycle, 111 and change. Here, in hertz. So that's the frequency of the first stair step. Then the other one is 97 and change. So I'm starting high and going low. Could do it the other way around. Doesn't really matter. Oh, the issue is like what value is that? Okay, I'm going to have to do some math for this. So 3.021 compared to 3.021. Oh, I didn't. Okay, so I have to paste and then like press enter or something. 2.827. So that's about 0.2 hertz, or sorry, 0.2 octaves. All right, about 0.2 octaves. Yeah, okay, so let's start with the, ooh, that is kind of confused. Okay, so if I mess with this checkbox while I'm editing this field, the right thing doesn't quite happen. Anyway, so that's my starting base value. Then my change is going to go up by 0.2. And I'm going to add another one. This UI also needs to be replaced, I know. Oh, I added these two sliders. I'll show what they do in a minute. This is going to be negative 0.2. So essentially what's happening over here is it's oscillating between those two frequencies. And if I make this happen fast enough, I should get something resembling what I have over there. So like the... Yeah, there we go. That's the closest I've been to this. Yeah, okay. See, that's nice and dirty. You know? I'm going to copy this. Let's put it into a layered thingy. So here's the stair step. I didn't have to copy that. Just copies on its own. Let's add a flat layer. Okay, this won't really be... Well, all right. So I can just solo this. Or solo this. Well, sure, and your frequency is wrong. Let's take the average frequency, which I can measure now. All right, so how many cycles is that? That's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17 half cycles. So 16.5 of these will give me the average hertz value. Sorry, 8.5. Oops, I went past. All right, 8.5. 106 and change goes... Oh, I can't... Wait, no, yes, I can. It's here, this hertz checkbox. All right, so let's compare. Yeah, same average frequency, roughly, with dirtiness, clean. All right, cool. And I don't know, I just kind of eyeballed this interval here. But, you know, first thing I tried sounded pretty good. So finally I have an answer to that. And now this is making me think, since that's an interesting sound, this is just like, this is a process of discovery. I'm seeing this is an interesting sound. I'd like to be able to more easily produce this than with this like messy stair-step process. Like, I guess a pulse wave sampler that alternates between two values at a certain average interval could make something like that, you know. Oh, shoot. Now see what that does. Okay, yeah, so my undo, one messiness about that is it's going to close all my windows whenever I undo, but that's fine. All the data is there. Right, yeah, the other thing I need to do is to make this be able to have, like, a reference of absolute time instead of relative time to the amplitude envelope, because when I lengthened that, it also stretched this out across the entire sound, and that's not always what I want. In this case, it was not, but I don't have a way to do it the other way around. Except I kind of do, although it's not exactly perfect. So I have this time multiplier slider here, which, you know, just can make this longer or shorter without messing with the individual steps, just as a whole. And this can be automated with controllers and stuff. It's neat. It's a useful thing to have. And value multiplier does basically same thing but vertically. So just stair steps, height up and down, you know. So anyway, so that's a mystery solved and an interesting sound created, and something I'd like to create a facility for making on purpose. Anyway, so that was fun. What else happened here? So yeah, those new facilities. I also have peak or valley, which doesn't mean a lot with square waves here, but let's go here and make a default sound here because I want to do some things with that. Send to audio editor. Ooh, you don't reset your zoom when I do that. You probably should. Okay. Yeah, so if I zoom in a bit, I can just snap to peak or valley, so it just snaps to either one. This is surprisingly fiddly to get right, but it works now. Or, you know, just snap to peak, just snap to valley, etc. Anyway, so what was I doing over here? Right, so again with the compression artifacts, let's just, for fun, see what that sounded like in this file here with all the extra ups and downs. I won't be able to hear much. I wasn't able to hear much before just because the section of the sound is so short. But yeah, if I zoom in on just, let's say, this bit and then highlight just you and I trim to selection, which is here. Zoom all the way out. Zoom all the way out the other way. Center everything. Okay. Yeah, this doesn't select all the way to the end. So I think what was happening before was like my selection went outside the bounds of the waveform view, and then it was examining a sample that was possibly like outside memory bounds. So I might have had an actual invalid memory access there, and that sample was throwing off the vertical centering. Therefore, it just didn't center. Anyway, so if I normalize that, sounds just about like as much of nothing as the other one. But let's hear something else. So here, I can kind of simulate compression artifacts. So I'm going to export aug. Untitled.aug, that's fine. Then I'm going to put an overlay here, untitled.aug. So it looks like it overlays pretty well. If I play the diff, it's almost inaudible. I could hear just a little bit there. But then I can send the diff to the audio editor. So this is one subtracted with the other. And then if I normalize this, so like this is what aug compression adds as a difference between the that sine wave and a raw perfect one. So anyway, just fun like this, normalizing this so we can see, like, hear exactly what happens, like what's lost with audio compression. Anyway, stuff like that's always interesting to me. So other stuff I did, not a huge amount. I mean, it was a bunch, but not a huge amount that's visible. I keep talking about this sample rate thing, and finally it's actually here. I have a preferences screen with one thing on it so far. So we're operating at 44,100 right now. I can operate at 48,000. Sounds the same. It'll be most obvious if I go to like a white noise or something. Yeah, you're loud. I get it. Can you be a little less loud? Sure. Yeah, so since the white noise basically just here, if I make it high frequency, why does that sound so weird? There's some artifacting. Whoa. I hear like a tone in there. Huh. I mean, that must just be an artifact of like the way I'm sampling this wave sampler, because you can see it holds its value until the frequency tells it it's time to change. So I think that's just happening at a regular interval, and that's coming through here. I never quite noticed it quite so audibly there, though. I wonder if I made something worse somehow by accident. Anyway, past a certain point... Okay, I think that's true white noise. If I just pin this at the maximum, like every sample in here will just have a new vertical value. So if I change this to a lower sample rate, like one of these, you can clearly hear the difference. Let's go even lower. Yeah, so an 11 kilohertz audio sample rate can't, just has literally no data any higher resolution than this. I can go even lower if I want to. Let's say 1,000. So that's what that white noise would sound like at 1,000 hertz. Not very good. So in addition to just affecting how this audio data is put together, that also attempts to set the host audio API's output rate to what this is. If I go out of range, 1,000 hertz is not something I would expect like a host audio API to be able to do, or I could just do like, some really high value like that. That's just a little bit above 96,000, which is a more or less normal one. Each of my platform audio APIs does its best to accommodate that request, and if it's unable to, it gets the next closest thing and then just resamples as it plays the audio. By the same token, I could take this over to the audio editor and change its characteristics without changing my preferences thingy. So I could say, this particular sound is at that sample rate. Right? Right? Yeah, okay, sure. Now you sound quiet. Let's amplify you. So yeah, some of these items work. I mean, I've been using. I can't really see what that does, but anyway, it just flips vertically, basically. This flips horizontally, basically. This one we've already seen. This one's unimplemented. These are all unimplemented. I don't know if there's a point to this, but maybe I'll put them in there. I feel like I should have that in a general purpose audio editor. The idea with these is they'd, like the ones with ... on them would show a dialogue asking like, how much do you want to amplify? This just does by 200% without asking, because I don't have the UI wired up for it. Anyway, yeah, so sample rate stuff finally worked out. I can also change this audio format to 8-bit if I want. That's going to be more obvious with a different sort of thing. Oh geez, you're very high-pitched. Sure, let's go back to that. I should choose a different default value for this, because like I know with some not so great speakers, 220 hertz is not extremely audible. So let's work with 440 for this. Whoa. Why do I hear... Why do I hear something that sounds like reverb? This... Is this my imagination? It's not happening there, just, I don't know, there was some kind of resonance maybe in the room with me. Maybe that doesn't show up in the video. Anyway, the resonance is gone. All right, I found the resonating frequency of my room or something. I don't know, I was hearing like, boo, woo. There was like a little extra thing at the end there, it sounded like. Anyway, right, yeah, so it'll be more obvious to hear what this does if I do that. Oh, right, and your sample rate is something silly. Let's set it to something normal. Yeah, so you can hear 8-bit artifacting. Or you can change this to floating point. I changed it from 8-bit, so it still had the same resolution there. But yeah, just like everything will be a little higher resolution for that. For this. I can change the channel count, but it doesn't do anything right now because this doesn't show multiple channels. On the inside, it has two channels now, and now it has one. And I can also do this thing if I want, where if I have some raw data and it's in the wrong sample rate and I don't want to resample it, I could say change this and don't resample, therefore this will be half the frequency. Anyway, so all that stuff is pretty much done. I probably have some debugging to do, but it's pretty good as it is. Yeah, and as I said, I have basic undo on this screen. You know, I can do those things. I can undo, I can undo, I can undo, I can redo. It beeps if I try to redo too many times. All this is doing is just copying the entire state of the parameters for the audio synthesizer. It actually does 2 copies per undo. It's very memory inefficient. I say very, but like if I did this, save in binary format, save as sound.stem audio. The memory structure is actually extremely compact. This is 90 bytes. Oh. So it's not much of a waste, but a more complicated one would be a bit larger. Or like if I'd, you know, load an entire song, this does the exact same thing. Like say this thing. Oh, why didn't you play? Oh, there it went. It just took a long moment to synthesize that. That was longer than I expect. Oh, and I can also send this straight to the audio editor. And it's going to be slow about it because that's a bunch of audio. Yeah, this is barely updating. This is around a minute and a half, same as the Explorer sound. But yeah, anyway, so yeah, let's see how big this thing is in binary. If I save in binary format and save a copy out here, composition5.stem music in binary is... okay, just over 5,000 bytes. Very small. I'm very happy with how compact all these things are. Sorry, did I say 5 bytes? 5 kilobytes. Just over 5,000 bytes, whatever, you know. Close enough. Anyway, yeah, so, but like, that's 5 kilobytes copied every single time I make a change, like that. Copied twice, in fact, because it's silly about it. So, you know, memory optimization, I could, whoa. Right, I changed that to octave 1 because this was highlighted. I tried to press 1 to go to a different screen, and that's what happened instead. This is a much more obvious optimization I need to make, like this thing just not being able to handle this much data because it looks at the entire thing it's drawing all at once. Anyway, yeah, so things are going fine. A lot of just like cleanup tasks, things like that, but it's satisfying to have a clean house, and paves the way for cool new features like, you know, these things that I was able to implement, solving mysteries like why the Explorer thingy was so different from my clean normal pulse wave. Yeah, so just this feels like it's really turning into a real program, and I'm very happy with the direction it's going. So yeah, I'm just going to keep at it and see how close I can get this to a releasable state. It's going to get there someday. But I got to pay all my debts first. So I'll see you next time with whatever I have.